Hi, my name is Antti Heino and I work as an AI advisor at SAS Institute, where I help our Nordic clients use analytics and AI. In this video, I will provide practical guidance and show you how to build and deploy responsible AI models. In many organizations, responsibility is embedded in their values to create long-lasting trust with their customers. But there is also increasing regulatory attention that requires professionals working with data to pay more attention to this topic. It is essential for organizations to make sure their AI models do not learn harmful bias from data. In addition, the development and deployment processes of models should be well-governed, ethical, and transparent. On artificial intelligence, trust is a must and not a nice to have. And this is said by the European Commission as well. There is, as I said, a regulation coming into effect on this area as well. And this regulation could enter into force in the second half of 2022 in a transitional period. And in this period, standards would be set up, mandated and developed as the governance structures would be operational. And the second half of 2024 is the earliest time the regulation could become applicable. So we still have time, but this is definitely an area we should look at closely. So, how is bias introduced in AI? We always use some sort of historical data to teach our algorithms to make predictions. And if there is bias in this historical data, it can affect the machine learning results, obviously. So if there has been like historical certain operational practices or way the data is collected, there is a strong chance that there is some sort of bias in the data. And this bias is then learned by the machine learning algorithm. And when it's learned by the algorithm, it's also contained in the predictions or the output the machine learning algorithm makes. And especially in situations where we would like to then use the output of this process to generate more training data, then obviously the bias swims back to the new training data and the cycle is ready. And this is obviously something we want to prevent with responsible AI practices. How do we do this in practice? I have prepared a demo, and in this demo we follow how Ethics AI Bank develops models to assess creditworthiness of customers and predicts who can pay back their loans. And we follow different personas through this demo. So first we have a data engineer who will assess bias in the data. Then data scientists who will develop transparent models. Deployment manager who will test and deploy this automated credit decision we will make. And a data science lead who governs the process. And obviously this is just one example, and there is not only one right way to approach this, and all processes can and should be modified to fit your situation. All right, let's jump to the demo. Here you can see the high-level process we will follow. I have set up this process in SAS Via, which is our analytics platform, and I can also proceed then to do all the phases, so assessing the data, developing the models, and deploying those models all in this one platform. We have done basically the defining the objective and the model proposal, so we know we are assessing the creditworthiness of our Ethics AI Bank customers. First, there will be the assessing data, privacy, and bias phase. Then we will develop the responsible AI models. And finally, operationalize those models through our decisioning capabilities. So this is a high-level governance structure that can be set up by the data science lead and the team. And we can drill down to the different sub-processes here and see how the workflow has been set up. So there are different user tasks and then service tasks that should be completed in order. So first, the data engineer will approve the data privacy, then the data bias, and then the service task will notify the next person that the previous step is ready. Then let's look at the data science process. So first we will build the model, assess the interpretability and fairness, and finally we will register the models and notify the next person, so the deployment manager, through a Teams message or a email, for example. And in the final step, so the deployment manager then sets up the champion and challenger models, so which are the best and the second best models. We will set up some model performance monitoring and reports aligned to that. Then we will integrate the models that have been developed into this decisioning logic, which is an easy way to create automated business decisions that we can then use to create real-time decisions in our process. And of course, if we find out anything that has affected the model performance, we can always launch the model rebuilding or model retraining tasks that are also part of this workflow. Okay, let's get to work. So first, we will act as a data engineer and we will look at the privacy and bias problems into data. And here you see how the individual personas act with the governance process, so we can claim different tasks for ourselves and then complete those in the other interfaces. So to complete these tasks, we will jump to this information catalog that we can use to find different datasets we might have available in our different databases. And in the background, there are these discovery agents running automatically and browsing through data, for example, to analyze the data quality, but also to find, for example, private information that we might need to look at. So our use case was about the creditworthiness of individuals. So let's search for datasets we have that are related to loans. And we can use free text search, different metadata items to find the data we are looking for. So in this case, we want to use this CS accepts data. Here you see the overview of the data. So we have 26 different columns, around 3,000 customers. So we have 3,000 customers who have either defaulted or not defaulted in their loans. So we can use that to create our predictive machine learning model. And here you already see how the data engineer can identify private information that can be in the data. So there are elements that can identify an individual, the age and the phone number maybe of the individual. And below we can also see how the row number has evolved over time. We can also look at sample data if we want to dig into the details by ourselves. For all columns, we can look at descriptive measures like skewness, missingness, so forth. So if you want to get an overview of the data, here's a good place to look at it. But let's focus on the privacy and bias assessment, as those were our main tasks. And here in data quality measures, we clearly see that title, age, and telephone have been identified as private information. And we can dig further into details of these variables. And for example, for age, we see that it's not anonymized and the ages are clearly visible. So this is something we just need to take into account in the analysis process and probably notify our data scientists that this is in the data. let's look at the title information. So that has been also identified as private, but luckily in this case we see that the title has been already anonymized, and we can use this in the analysis. However, we see that there is a strong bias towards the other of the titles, and this needs to be taken into account from the bias perspective. And finally, we can also look at nationality, and here we also see a potential bias problem. So most of the data is about German nationalities, so that can create a bias that affects our modeling results. We are now ready with the tasks, and we can complete our tasks in the workflow and notify the data scientists that the privacy was okay, but the bias in the data exists and it should be taken into account by the data scientist. Once the data engineer has completed the tasks she had in the workflow, an automated Teams message is sent to the data scientist so they know that they can start the work on their part. Okay, now we are ready to put our data scientists hats on, and in this demo I will mostly focus on explainability and fairness assessment of the models, not so much into the modeling techniques themselves. And what I really love about working with Vaija is that I can choose how I want to work. So first I will show how a citizen data scientist would approach this problem with visual tools. And then I will show also how an open source data scientist can work on Vaija using Python code and develop similar models with code. So let's see how the citizen data scientist would approach this problem in our pipeline interface. And here you see a selection of projects, modeling projects we have in the tool, and we can either create a new one or choose an existing project. So let's open a project we have created, and first you will see this data pane where we have the CS accepts table open that the data engineer has prepared for us. And here we see the target, so the good / bad, so the outcome of the loan for the individual customer, so either whether the customer has defaulted on the loan or not. So that's the binary outcome we want to model. Then we have the nationality, residence type, and title variables that have been also selected with the check mark for bias assessment. And that's really important, as we identified in the previous phase that there might be some bias issues with these variables. So first we can check the pipelines, and as you see we can either have predefined pipelines or create our own from scratch, so it's up to the user. And if we want to create new pipelines, we can start those from templates, and here we can select a best practice template that has been previously created. We can also automatically with AutoML create pipelines from scratch using our built-in AI capabilities. So if you would like to extend this ready-made template, there are the different nodes over on the left side that we could use to extend the pipeline if we would like to. But in this case, the ready-made pipeline is good enough for us. For each of the modeling nodes, we can turn on these interpretability features in the options. So we have global interpretability methods and also local interpretability methods we can use to understand why our models give a certain type of prediction. And this is really important, especially for industries that will be regulated by the EU regulation, for example, the finance industry. So let's run the pipeline, and at this moment the machine learning models start looking at the data and trying to learn the patterns in it and creating the best possible predictive algorithms. So we have logistic regression, neural networks, decision trees, gradient boosting, random forests, training on the data. After the training has finished, we can look at the modeling results. And here we see a comparison through all of those different algorithms. So we can easily try different algorithms and see what works best. And it seems with these metrics, the ensemble node or algorithm has won the tournament. So the ensemble model is a combination of the individual models in the pipeline. And that's why it's a little bit harder to interpret. And in this type of case, especially the model interpretability methods are really important. So we have visuals on all of those. And for example, with partial dependence, we can see the average effect of different input variables to the prediction. So we see, for example, how income affects the default risk of the customer here. In addition to PD, we also have ice, lime, and hypersharp values here and in their graphical format as well. Let's expand the sharp values, and here we see how the age, for example, affects the prediction. So for value 23, the estimate increases by 0.14, and if the customer is without vehicle, the estimate increases by 0.06. So here we can see quite easily how the final result of the model's prediction is created through an aggregate of these results. Of course, we have, in addition to the interpretability methods, we have the standard assessment metrics like lift and ROC curves that we can look at. But let's focus this time more on the fairness and bias assessment. And in the fairness and bias tab, we see that there is a huge maximum prediction difference in nationality, but not in the residence type and the title. So there is some type of problem certainly with nationality. On the top left, we see also that there is a huge maximum metric difference, for example, in the true positive rate, also in nationality compared to these two other variables. And in the lower tabs, we see the performance bias. So there is quite a big difference between the true positive rate between the nationalities. And we, for example, see that for some nationalities, just based on the nationality, the customer gets a really high risk or really low risk. So this is something that we don't desire in our model. However, from the prediction bias, we see that for German nationality, the average prediction is quite okay. So we might consider using this model for German nationalities, and then let the other data scientists maybe to develop another model that we can use for the other nationalities. And after the model is ready, the data scientist can easily register the best model to centralized model management. Great, the model registered successfully. Next, we will look at the same process through the eyes of an open source data scientist. And here we see how we can use the power of VIA also through Python code. So there is strong open source integration with SAS VIA. And here we see how we are able to connect to the same environment, get the data, and build the models, use the same bias assessment here in Jupyter Notebook as well. All you need to make this open source integration happen is the first import package there, so this SWOT package. So that enables you to get connection to your SAS Via server and use the data and the processing power there for your analysis. I will skip over some parts like the data exploration and partitioning, but here you see how we can train decision tree model and a gradient boosting model on the same data we used also in the visual modeling interface. We can run also the same bias assessment tools here in the notebook. And here you see, for example, that in this model, the true positive rates for the different nationalities are much better balanced than in the previous model. So now we can consider maybe using this model for the other nationalities and the previous model for the German nationality to prevent bias and certain predictions just based on the nationality. And with a couple of commands, we can also register the Python model here to the same centralized model management. And next, we can jump to the deployment manager tasks. And here we will take a look at some of the model monitoring and especially the decisioning capabilities we have. Work of the deployment manager starts typically in the model management interface. And here we can see an overview of all the modeling projects we have in the organization, and we can drill down to individual projects. And in this case, we want to look at our credit risk modeling project. And here we see the ensemble and gradient boosting models that were developed in the visual interface and in Jupyter Notebook interface. We can create a final comparison of the models before we decide how we want to take them into production. And here we can compare the two models side by side. And we see that, for example, according to the C statistic, the ensemble is a little bit more accurate. But as we know, we have to deploy it for the German nationality only, and the gradient boosting model seems to be almost as accurate, and we can deploy that for the other nationalities. And here are also other statistics related to the model accuracy. For responsible AI, it's also very important that we monitor the performance of our models once they are in production. So after the models have been functioning for a while in a production environment, it is important that we use the model management capabilities and the performance monitoring reports here to follow up on the accuracy and the input data of our models. So we see that they are still functioning as they should be when they are used in production, especially if they are used for automated decisions regarding an organization's customers. And these are automatically created for you, but you can also add your own and customize these if you want to. The deployment manager now has two models that need to be taken into production so that they can be used to create automated credit decisions for the bank's customers. And the easiest way is to use one of my favorite capabilities in Via, so our decisioning engine. And here we can easily create these decision flows that create those automated decisions in real time for the bank's customers. And part of it's already pre-built, and we can just easily add our predictive models to the decision. So basically we are saying that if the nationality is German, use the ensemble model, and if it's not, then we will use our gradient boosting model. And here we can also easily create these business rules in addition to the models, because for many business processes, the predictive model is just not enough. So we need business rules as well to add additional logic. And This way, it's easy to keep track of all the business rules as well, so we don't have to hard code anything into code. And for responsible AI, it's also really important that we are able to test these decisions. So we know once we publish the decision, what will the actual results be. And for this, we can use a test dataset and run that through the decisioning logic. And we can run this rules-fired analysis, which shows us which of the rules have been fired. So we see what kind of decisions our entire flow makes. And we can also run the path tracking, and especially for more complex decisions, this is a really useful feature. So here we see graphically how the customers are allocated into different buckets in the decision flow. And this way we can make sure that we don't end up doing any unintended classifications for the customers. After the decision has been running in production for a while, it's important also to follow the end results from that. And here is a dashboard we have built to analyze the results. And here we see that, for example, if you look at the low risk to default category, it's quite nicely balanced among the title in the top right corner. Also now for a nationality, the low risk to default is quite nicely balanced among the nationalities in the top left corner. So here we see that the decisioning logic and the split to different two models are working, and now we are not biasing our decisions based on nationality. In your case, the sensitive variables might be different, but hopefully this has given you a good overview on what kind of tasks can and should be done in your data science process so that you are able to create responsible AI models. Hopefully you enjoyed this video. Thanks for watching.